Good morning, my name is Carrie Dunaway, and my cellular communication project is on primary cellular dyskinesia, otherwise known as PCD. So first off, cellular communication is how cells communicate with each other. It can be done short distance between neighboring cells or long distance by secreted signaling molecules. Signaling is used for regulating interaction between different types of cells during embryonic development and for maintenance of adult tissues. There are 3 steps to cellular communication called the signal transduction pathway. The 3 steps are reception, transduction, and response. So you can see the signaling molecule bind to the receptor protein, and that sets off transduction. And transduction is several steps of translation, and then once it's transduced, it is responded to. So a cellular communication disorder is simply defined as a disruption in functional signaling between cells and can happen in any stage of the signal transduction pathway. So PCD is a rare inherited condition that affects the reception stage of the transduction pathway. Primary cilia act as signal receptors like antennae on the surface of cells. With PCD, it makes the primary cilia motionless, ineffective, or absent. If the primary cilia are unable to receive signals, then it leaves the cell unable to communicate. So primary cilia are found on every one of your body cells, and there is usually 1 primary cilium per cell. With PCD, it makes the primary cilia motionless or ineffective or absent, and it just leaves them unable to communicate. And that especially in the hedgehog signaling pathway, and with regulating various other homeostatic functions. So here is a simplified graphic of how the signaling pathway works in the primary cilia. So there is receptor proteins in the cilia membrane, so that's how reception starts. And then the signal goes down the axoneme, and that's transduction. Then it reaches the transition fibers, and it's kind of like a gateway. It keeps certain signals out and lets the ones that need to go through. And then basal body is where response happens. So this is like a top-down view of the axoneme, and so a cilium has 9 outer microtubule pairs and a central microtubule pair, and they each have nexin links, dynein arms, radial spokes. The radial spokes connect the outer pairs to the central spoke. The nexin links connect the outer pairs together, and the dynein arms basically just keep the signal traveling down correctly. So the primary cellular dyskinesia also affects the modal cilia in a way that it keeps the mucus from clearing from the lungs. But it also causes the lungs to be formed incorrectly through embryonic development because it messes up the hedgehog pathway. So specifically, it affects the primary cilia's ability to send and receive signals for what type of cell developing cells will become. In the lungs, that affects what cells are meant to be airway epithelium, smooth muscle, or other branching formations. And here is another graphic of the pathway, as well as some real pictures. And then this is the hedgehog pathway. It's used for cell growth and differentiation for cells, for formation of tissues and organs in the embryo. And if this is defected, then it causes malformations in the embryo. So PCD is typically autosomal recessive. There are several genes, over 50, that are causes, and some of the genes are DNI1, DNI2, DNAH5, and DNAH11 are all responsible for encoding proteins for the dynein arms, as some examples. Like I said, over 50 genes responsible have been discovered, and they can all be on various chromosomes. It's usually in autosomal recessive manner, but X-linked and autosomal dominant forms do exist, but this shows how it would be passed down in an autosomal recessive manner, where each parent is a carrier, and then the children have a 25% chance of having it. So here is a few different ways that it can be shown with the primary cilia being messed up. And this first one is missing the outer dining arms. And then some of these, for example, this one has an extra central microtubule pair. Some of them are missing the Nextin links that connect them to each other. Some of them are missing the radial spokes that connect it to the center. So the most common symptoms are the chronic respiratory infections, sinus inversus, digital clubbing, medical intolerance, chronic ear infections, and hearing loss. Several symptoms are malformations at birth, and there is nothing you can really do about that. But a lot of them are also just caused because they still can't communicate throughout life. So here is an airway with PCD. As you can see, the modal cilia in that line the lungs epithelium still can't clear the mucus from the lungs. And that causes most of the chronic respiratory infections that you see with PCD. And then sinus inversus. So the thoracic and abdominal organs are abnormally mirrored. And that doesn't have many symptoms in itself, but people with sinus inversus usually have all the symptoms that come with a respiratory infection. So this doesn't actually have any issues. Most people that have it never even find out that they have it. So there is no cure, but the infections for basically their entire life have to be treated with antibiotics. And the mucus buildup in the lungs can be treated with machines to break the mucus loose. And even though it can't be prevented, it is best for there to be an early diagnosis so they can go ahead and treat some of the issues to prevent lung damage. About every 1 in 7,000 to 16,000 people globally are affected with PCD, and about 1 in 12,000 to 1 in 17,000 individuals in the US. However, a study done by Indiana University in 2022 actually showed that PCD is a lot more common than scientists previously thought. So numbers are constantly being recalculated. So it affects people from all ethnic and racial backgrounds. It has been found to be more common from African ancestry, or specifically in white Canadians too, but it really can just affect anyone. The main risk factor is just having both parents be carriers for the disease. So there, like I said, there is no cure, but they have been developing a gene therapy to treat it that is a form of inhaled mRNA, which goes directly to the lungs to correct specific gene defects like CCDC40 and DNAI1. So for many years, all PCD patients were diagnosed with cystic fibrosis because they thought that PCD was just a milder form of it. It presented basically the same, so they were just treated like cystic fibrosis patients, just in a little bit a milder way. So, but it led to a lot of misunderstandings towards the difference, so it put them behind on further research. So they put themselves behind on developing treatments, and the gene therapy could have been developed a lot sooner, but since they were so behind, they had to make up for lost time. So they basically moved past trying to get over the root cause of it and moving to more innovative treatments after birth. And that is my presentation. Thank you for listening.